Okay, guys, let's look at this next question from CAT 2021, and you can just give it a try. Okay, so there are multiple ways to solve the question. First is we can directly use the concept of quadratic equations. So if r is a constant such that mod of x square minus 4x minus 13 is equal to r has exactly three distinct real roots, then the value of r is. Okay, so if the equation has three distinct real roots, guys, what we mean to say here is, see, this is mod of fx is equal to k, suppose. Okay, so if this particular equation has three distinct real roots, this can only happen when fx is equal to plus k or fx is equal to minus k. Exactly one of them will have two roots, the other will have one root. Okay, one root or two roots also, right? This is the only way in which we can have overall three distinct roots for the given equation, right? Okay, so what you can now do is you can just take this as, let's say, two cases. First case is when x square minus 4x minus 13 is equal to r. The second case is x square minus 4x minus 13 is equal to minus r. Okay, we can frame quadratic equations in both the cases, and then we'll use the concept of b square minus 4ac to check what can be the possible value of r, right? So if you take r on the left hand side here, you will have x square minus 4x minus of 13 plus r is equal to 0. And on this side, we'll get x square minus 4x minus, okay, 13 minus r is equal to 0. Exactly one of them will have one solution, right? So b square minus 4ac for exactly one of these two equations must be equal to 0, right? Only then we can have one unique solution, right? Or one repeated root, I would say. So let's check the b square minus 4ac value for this quadratic equation. So b square minus 4 into a here is 1 into a into c here is minus of 13 plus r. Okay, b square minus 4ac here should be equal to 0. That gives me 16 plus 4 into 13 plus r is equal to 0. Okay, taking 16 on the right hand side and dividing by 4, you have 13 plus r is equal to minus 4. That will give you r is equal to minus 17. Okay, that's one possibility. All right. And if you take the b square minus 4ac for this quadratic equation, you have minus 4 square minus 4 into 1 into minus of 13 minus r. Okay, b square minus 4ac should be equal to 0. You will get 16 is simply equal to minus of 4 into 13 minus r, or minus 4 is 13 minus r. You will get r is equal to, 13 here, minus 4 on the right hand side. 13 plus 4 will give you 17. Okay, so either ways, you're going to get r is equal to plus or minus 17, depending upon how you open the mod. So that gives us the value of r as 17, right? That's one way to solve the question. Okay, guys, the other way, or a much quicker way to solve the same question will be, you can observe this equation, guys. As I said, we can have three solutions in only one way, right? Exactly one equation giving you repeated roots, one root only, and the other equation giving you two roots, right? So if you observe carefully, this is of the form x square minus 4x minus 13 is equal to r. Okay, now if this is forming an equation which has only one root, you can open this using a square minus 2ab. So the next term should be b square, right? Plus b square. Okay, in that case, or in this way, you will have, okay, and this is the only way in which you can have a quadratic equation, which is of the form of a perfect square, right? So x minus 2 the whole square. This will have repeated roots, right? Now for that to happen, the minus 13 here should be replaced by plus 4, right? And that will happen only if you're adding, okay, plus 17 here, right? So the value of r has to be plus or minus 17, depending upon how you open the mod, such that if you have x square minus 4x minus 13 is minus 17, minus 17 on the left hand side, you will have x square minus 4x plus 4 is equal to 0. And that's how you get this quadratic. So directly you can say the answer will be option C.